Hi everyone, this is Ningxi with Data Science Dojo. Today we're going to introduce some very useful functions including group by, summarize, and arrange to start manipulating your data. We're also going to walk you through some basic visualization techniques with Ggplot. As you can see, just a few simple lines of code can create beautiful plots. So one of my favorite tools to use in dplyr, and I think this applies not just with to dplyr, but data analysis in general, is a group-by-aggregation combo tool that we can use. So it basically groups the data set by a certain feature, and then it performs some aggregation function on the subgroups, which comes in really handy if we want summary statistics on the different subgroups to do a quick exam of how the different groups are differing our data set. Then group by aggregation is one of the most powerful tools you're going to use. So the first function we're going to demonstrate with that is arrange. Also note that this syntax in dplyr, it's called the pipe operator, and it's very handy when it comes to passing multiple functions sequentially, since it takes whatever object that comes immediately before it as the object that it's going to use. So I'm going to do the group by aggregation, which in dplyr syntax will be group underscore by, that's its own function, followed by summarize. So here we're going to group by country because we want summary statistics on the different countries, followed by another pipe operator. So whatever function comes after this operator is going to take whatever object created by this function as its argument, so on and so forth, which is very useful. We'll do group by and now summarize. We want to count how many wines each country produced in this data set. So when I do this, it means that I'm creating a new variable, and I could have named this variable whatever, but I'm naming a count because that makes sense. I'll do another function inside the summarize function named n, and it does not take any argument in the parentheses. So here it's counting all the observations grouped by country, and then creating a new variable called count. So right now we're creating a new data frame that only has two columns: the column that we selected by group by, which is country, and the column we just created called count inside the summarize function. And we want to know what are the top producers in this data set. So we'll do something like arrange. That's going to sort through all the values. Because arrange has its default setting as ascending, means it's going to start from the lowest value to the highest. We want to do something like DESC, standing for descending, by count, since we want to know, we want a top to bottom count, so from the largest to the smallest value. So when we do that, we get, like I said, the two-column data frame that only has country and count, and we see that the top 10 producers are listed, with 30 more countries not listed. So there are 49 countries in total in the set. Because of the magnitude of this data set, we want to focus our attention on, let's say, the top 10 producers. So I'm going to actually create a new variable called selected countries. That's going to do just that. Again, I'm going to start with our original data set Y, group by country. And summarize by count. Note that the n function is actually the function that's counting, and this count is just any name that I chose to give it. So this is just repeating my previous line of code. Here I'm introducing a new function called top_n, and inside it I can pass any number I wish. Here I can do 12 or 15, but I'm going to select the top 10 producers, so I'm passing 10. Finally, a select function that's going to let us select which columns we want. And note that it only works with subsetting columns, not rows. We'll see how to subset rows shortly. Okay, so here I actually forgot to pass count inside the arrange function because otherwise it does not know which variable I want the count to take. So if it was taking the variable country, then it doesn't make any sense. So remember to passing count into the arrange function, and now selecting by count. And if we examine this new object we just created, it is actually a data frame. If we check out its structure, we go, which we do not want because, as you can see later, we want this object to be in a vector structure so we can directly reference it. So the way to do that is overriding this object using the asCharacter function. And because this object is still a data frame, I can use a syntax to reference which column. Even though it only has one column, I still need to do the $ syntax to explicitly say that I am selecting the country column. So now if I check this out again, it's now a character vector. Just make sure. There we go. So if we want to create yet another data frame containing only data on these top 10 producers, and we want to find out how their wines were rated in the set. And that's, as you can see here, accomplished by the points function. So we're going to subset again. Let's create a new object. Let's call it select point. Starting from our original data frame, and here we're using this function called filter, which is used for filtering rows. So as opposed to select, which works with columns, filter works with rows. We're saying that we only want the rows that appear in the selected countries list. So note the syntax here. This function is basically saying that we only want the rows that have their value in the country column over here. If their country is listed in this vector, which is here, as you can see, the top 10 producers list that we came up with a moment ago. So we're gonna select only certain columns out of this data frame. So we only want the country and points columns. And we'll do another arrange by country. And if we check this object out, we'll see that it is a new data frame containing only the top 10 countries we selected and their points. And skipping most of the values because there are too many rows. If we want to do a quick examination of how the variable points moves with price. So in other words, we want to know if a more expensive bottle of wine really is better, or at least so judged by wine enthusiasts, where this data set is obtained from. I think that's a question most of us encounter when we try to pick a good bottle of wine in a store or at a bar, because oftentimes we don't know if more expensive really does mean better. So let's do a quick exam there using Ggplot. I'll do a scatter plot, so passing the geom point function after the ggplot function. And I'll also add a smooth line just to make it visually easier to see the trajectory of the correlation. And it's taking a second here. As you can see, where the system's still running. We'll go over to plot. We can see that overall there is a positive correlation between points and price, even though it's not a huge jump. And a few outliers here. You can see the most expensive wines. I don't know why this is taking a while. The most expensive wines located towards the top of the graph do seem to be highly rated as well, except this guy right here. So rest assured, if you are paying more for a bottle of wine, chances are I wouldn't say very likely, but likelier than average, say 50%, that you are actually getting higher quality than average. So that's interesting to know. And if we want to delve into the country-specific details of how their wines were rated, we can do a more specific plot, or in this case, actually a series of box plots, and see what we get. So I'll pause here before I type in more code. Here I'm saying that I want my the variable on the y-axis to be points, pretty straightforward. On the x-axis, I want country. However, this variable is going to be reordered by the points column, and we're saying that we want the median of points to be the reordering metric when we are placing these country values on the x-axis. So moving on to calling the box plot aesthetic. We're gonna fill these box plots by country. Remember to use fill instead of color, because color only does color the outline of the box plots. It does not fill the entire box. Finally, we're adding some labels to our plot so it looks pretty. Don't remember to use quotes. And we can also add a title. Let's say distribution of top 10 wine producing countries. Here, I'm just gonna make sure that the title appears right in the center. So I'm gonna do something like element text, since we're gonna move the textual element, and passing the hJust argument, which stands for horizontal justification. I'm going to set it to 0.5 since this is usually treated as a value between 0 and 1. So 0.5 means it's going to be horizontally centered, essentially. Let's see what this gives us. So here we have a series of box plots of our top 10 producing countries ranked by their median point. We can see that on average, or by the median metric, France is the highest rated country in terms of wine quality, even though it does not vary a lot from the runner-up Austria. One caveat when working with this data set is that all the observations are wines that received a rating of 80 or more, since wine enthusiasts did not even include wines that received a rating below 80. So the distribution may be a little tighter since all these have been essentially pre-filtered, pre-vetted before they were even included in the data set. So here we can see that we have some countries that have a wider spread, like the US and Spain, and some have tighter distributions like New Zealand, Italy, and Austria, and some outliers across the board, really. If we want to find out if there were any countries that produced high quality wines, but are not mass producers, meaning if they're not in the top 10 producing countries like we found here, but nonetheless produced wines that were rated high, we can do something like the following. So this time around, we're going to filter by countries that do not appear on the selected countries list. So we'll do this syntax. So the exclamation point, like in many other programming languages, just means that we're saying exclude, that we're selecting countries that are not in this list. So continuing the piping sequence, I'm going to do another group-by-aggregation function, grouping by country again, and then summarize. This time around, we're going to create a new variable called median. That's going to be created by doing the median function. Don't be confused here on the points variable. I'm going to do another arrange. Again, descending order, since we want the top the top rated wines to come up first. So here we go. After filtering for countries that do not appear on the top 10 list and arranging by their median point, we see that the top high quality wine producing countries are England, India, who would have thought, right? Germany, okay, Slovenia, Canada, Morocco. That's an interesting one as well. So on and so forth. So keep an open mind when you go wine shopping next time. If we want to find out which countries not only produce a large quantity of wine, but also do offer high quality products, we can do an intersect function and find out where the intersecting rows are into data frames. Also, it's a handy tool to use with dplyr. So here I'll quickly create another variable called top. And here I'm not filtering by any rows. I'm just going to do a quick group by aggregation again. Group by and summarize. Same thing as before. Want to use a median point as a metric. So here, if you check it out, it's actually going to be a data frame structure. We're going to transform that into a vector. So overwrite it. We're only selecting the country column. So there you are. These are the countries that are most highly rated in terms of their wine quality. So this includes both the top producers and otherwise. By now, you should be able to properly select columns and filter rows, as well as using Ggplot to work with dplyr to create seamless visualizations. In part 3 of this introduction to dplyr, we're going to close out by introducing intersect and setDiff functions to show you how to find overlapping and distinct values from two different data sources. We'll see you soon.